Hey folks, hope everyone's doing well. My name is Ben Shapiro. In this video, I'm going to kind of show a little activity teachers or teaching assistants can do, particularly for university students, that takes the classic philosophical trolley car problem and kind of tries to make it really relevant to a computer science context and hopefully an enjoyable way for students. So to do that, we're going to look at the context of autonomous vehicles in one very small particular way. And at the bottom of this page you're looking at here, you'll see a link. Go ahead and go to this link. It's by a really wonderful designer and artist named Matthew Cherubini. He's fantastic. You got to look at the rest of his work. I'm going to click that link and go to it now, and you'll see what I mean here. Make the page a little bigger. And on his site, he's developed a platform that you can download and simulate autonomous vehicles operating under different algorithms in different types of scenarios. It's really inventive, really wonderful. If you scroll to the bottom down here, you'll go ahead and you'll see kind of different ways you can download what really is kind of like a simulation. It's almost like a video game. So we encourage you to give this to your students and have them download this simulation to learn a little bit about different types of algorithms and simulations. But we also say to introduce the activity, do what I'm about to do here, or something like it. And what I'm going to do is I'm going to click this little thing here. I'm going to blow up, but there's a video on the page, and you can use the first 3 minutes of this video to introduce the activity to your students. So this video kind of actually goes through what you do in the video games. So I'm going to go ahead and start this video, and I'll pause it for a second so we can talk about it. It begins by illustrating a scenario, or a particular scenario that involves a school bus and one autonomous vehicle or one self-driving car that is operating under the humanist algorithm. And as you can read here, the humanist algorithm, this is an algorithm that Matthew has invented, just a very general algorithm. It shares the damage among all the people involved in the crash. If possible, deaths are avoided. Less damage is inflicted to the weakest group of a given population, which is the most vulnerable to physical trauma, such as children, elders, and so on. So I'll keep playing the video here, and in a moment, what we're going to see is a car is going to drive up and meet a bus on a bridge, and the car is operating under the humanist algorithm. And you might ask right now, well, what does operating under the humanist algorithm mean, and what does it result in, right? So the first thing you'll see in this kind of video that's showing what the simulation does is it does some profiles analysis, figures out there's 57 male and 28 female passengers on the bus, 16 of which are children. All right, you could critique that in various ways, certainly. It finds 3 different paths and calculates collision odds, injuries that might result for children and adults on each different path, kind of talked about as predictive risk analysis. You might ask, what data is informing this predictive analysis? Probably a good question. Calculates, of course, extreme injuries, how many deaths would be involved on each path. Makes a fairest path calculation, and that's the result, right? So in this case, the humanist algorithm took the car head-on into the bus. The simulation gives these amazing crash reports. I'm just going to pause it here. So again, that vehicle was operating under the humanist algorithm. The crash conclusion, a frontal collision with the bus, is the fairest output because the 2 others could lead to death cases, something that the humanitarian algorithm tries to avoid at all costs. So we get some justification for how the algorithm operated, right? So obvious questions is, well, how would other algorithms operate in the same scenario? So we once again have the same school bus scenario. I'll pause the video here. This time, the protectionist algorithm is going to be used to operate the car. As described by Matthew here, similar to how our cars are designed, the protectionist algorithm attempts to protect the vehicle and its driver at all costs. This algorithm is safe from a user perspective, but unsafe for everyone else because it dismisses everything and everyone to preserve the user's safety. Pretty interesting, right? So we might think, well, what's the car going to do now in the same scenario with the protectionist algorithm, right? And so, of course, let's watch the results, see similarities and differences. Gets the user information this time, a bit different than last time. Detects obstacles as before. We get a similar selection of paths. A similar risk analysis. And finally, a really different result. with the car being safe, and this makes this a lot more serious. We now have a school bus rolling off the bridge, correct? Let's look at what the heck the crash conclusion would say on that, right? Protectionist algorithm, crash conclusion, no matter how many children are in this school bus, the autonomous vehicle has to keep its owner safe, right? So, as I was saying before, the severity of this, the seriousness becomes much more visible now, right? You might be asking, which algorithm do we want operating a vehicle? Of course, there's many more ways to look at this. One single algorithm probably wouldn't get the job done. But in discussions with your class, when you start looking at different algorithms and in different scenarios, raises really provocative questions. Let's look at one more algorithm in the same scenario, right, involving the school bus. This time it's the profit-based algorithm. In this case, the profit-based algorithm, new insurance policies are emerging for autonomous vehicle crashes. The profit-based algorithm chooses the best possible outcome depending on the user's insurance policy. It also tries to favor the protection of famous people, celebrities, politicians. I'll stop there because you can watch this video on your own with your students. You can see what happens. I will say that Donald Trump, setting politics aside, makes an appearance. And so this is a really provocative way to bring a small snippet of discussion around autonomous vehicles and decision-making and algorithms into the classroom, right? So after you've had your students download, run these different simulations and experience these different types of algorithms, you want to give them a prompt to kind of allow them to really reflect, discuss together, or consider alone, lessons learned and things they can be thinking about through this activity. So this is a prompt we use. Feel free to use the exact same one, customize it, create your own. But I'll just read through it here. It starts with using the profit, protectionist, and humanist algorithms as examples. Invent a different algorithm, your own algorithm, to operate an autonomous vehicle. Consider how your algorithm works and what data it uses. And finally, draw a diagram to show how your algorithm operates in a particular scenario. So we've used this prompt in online courses for kind of synchronous or asynchronous discussion online. We've also used it, of course, in face-to-face classes where different groups will create their own algorithm together, and then they'll share and compare across different groups. We do strongly encourage you to have your students make a visual diagram. Matthew on his site has some really great kind of block diagrams that show how different algorithms are working, so you can share those as examples for your students, but having them represent their thinking is a great way to bring this kind of activity together. So with that, I'll kind of conclude the video. We hope this has been useful either to inspire you to think about your own creative activities, ways of bringing in ethics into CS and to address these types of problems, or also just feel free to use this exact activity and customize it for your class. Okay, thanks so much for your time.